Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we are going to see how we can detect simple geometrical shapes using OpenCV. So to start with, I have this simple code which reads an image and then show it into a IamShow window. So let's run this simple code first of all, and let's see what it does. So you can see I have this image which I'm loading into a OpenCV window using IamShow method, and here we have some shapes. So we have a pentagon, circle, rectangle, square, triangle, and this star shape, right? And let's say we want to detect using OpenCV which shape it is based upon the geometrical shape, and we want to write the name on top of this shape. So how we can achieve this, let's see using OpenCV. So as you can see, the first step is to read an image, and then in the second line I'm just converting this image into a grayscale mode image. So using this code I'm just converting this image into a grayscale mode, and in the next step we are going to find out the threshold. So I'm going to just say underscore comma thresh is equal to cv2 dot threshold. So cv2 dot threshold, and we are going to pass our image, which is a grayscale image which we have converted as a source, and then the next two values are the threshold values and the maximum value of the threshold. So for now I am giving the threshold value to 40 because I know this will work, but if you want to be more flexible you can always use the track bar to find out which threshold will work with your image. The second value is the maximum value of the threshold, and the next value will be the type. So the type here will be cv2 dot thresh binary. So we are going to just say cv2 dot thresh binary. Now in the next step we are going to find out the contours. So contours we have already seen in the last videos, how to find out the contours and what are contours. So for that I'm going to define two variables. One is contours variable, other is the underscore variable, because we don't need the second result. And then I'm going to just say cv2 dot find contours. The first argument here will be the thresholded image, and then the second argument here will be the mode, and third will be the method. So let's give these two values. So cv2 dot retr tree, and the method will be cv2 dot chain approx none. Okay, so let's give this method. So this is the simple procedure to find out the contours inside an image. Now in the next step I'm going to iterate over all the contours. So I'm going to just say for contour in contours. So we are going to iterate over all the contours, and then we are going to first of all use a method called cv2 dot approx poly dp. So I'm going to just declare a variable. First of all I'm going to just say approx is equal to cv2 dot this method which I have mentioned, which is called approx poly dp. So this method approximates a polygonal curves with a specific precision, and the first argument which it takes is the curve. So our curve here will be the contour which we have found on the shape. The second argument here will be epsilon. So epsilon is the parameter specifying the approximation accuracy. So here what we are going to do is we are going to define epsilon is equal to 0.01, and then we are going to multiply this number by cv2 dot arc length. So there is this method called arc length. And what does this arc length method do? It calculates a contours parameter or a curve length. So here in this arc length parameter, we are going to pass once again our contour variable, and the second argument here will be if it's closed or the open contour. So in our case, we know that all the shapes which we want to detect are closed, so we are going to just pass through here. And the next argument in the approx poly dp method will be once again if it's a closed shape or the open shape. So once again we are going to pass through here because all the shapes which we have are closed shapes. Now once we have this approximation, we are just going to draw all the contours first of all. So we are going to just say cv2 dot draw contours on which image? On our original image. So we are going to draw these contours on the original image, and then we are going to pass the second argument, and this will be our approximation. So we can in the square bracket, this is one other notation of just giving the number of contours as an argument to the draw contours method. So in the square brackets you can just pass the approx. The next parameter here will be the contour index. So because we are iterating over all the contours, that's why the index will always be 0, because there will be only one contour which we are working at a time. So this index will be 0. The next argument here will be the color. So you can give any color here. I am going to give 0, 0, 0, let's say. And then the next will be the thickness. So thickness I'm going to give here is 5. Now the next step is to print out the shape. So which shape it is, we want to print on the shape, which shape it is in simple English, let's say. So for that we need to find out the coordinates on which we want to print this text on the shape. So we need to find out the x and y coordinates. So we can find this x and y coordinates using this approx variable, and we can just say approx dot revvel. So this is a method called ravel, and then the first index here will be the x coordinate, and in the same way we are going to just say approx dot ravel, and on this method the second argument or the second index at index 1 will be the y coordinate. So on these x and y coordinates we are going to print our text. Now in the next step what we are going to do is, so because this approx poly dp is going to approximate the number of polygonal curves, so based upon the number of polygonal curves we can just approximate which shape it can be. So if this approx length, so let's just find out the length of this approx, and if the length of this approx variable is equal to 3, then we are going to say that it's a triangle, because triangle can be made with 3 points. So this length of approx variable, if it's equal to 3, then we are going to say that it's a triangle, because if the number of curves here are 3, then most probably it's going to be a triangle. So if we know that this is a triangle, then we can easily just print or put text on that image. So we are going to just say put text, and the first variable here will be the image. So we are going to put text on the image. The second variable will be the text, and we know that this will be a triangle. So we are going to just say triangle here, and then the next argument here will be the coordinates on which you want to print this text. So we already found out the coordinates at which we want to put this text. The next argument here will be the font. So we are going to just say cv2 dot font Hershey complex, and the next argument here will be the font scale. So let's say font scale will be 0.5, and the next argument here will be the color. So you can give any color. Let's say we just want to print this text in the black color itself. So we are going to just say 0, 0, 0. Then using this logic, we can also say that if the length of this approx is equal to 4, then it can either be a square or a rectangle. So here, if the approx length is 4, then it can be a square or a rectangle. But we don't know if it's a square or a rectangle. So for now, we can just write that it's a rectangle, and we are going to decide if it's a rectangle or a square in the next step. But let's define the other if else conditions also. So this was elif. Similarly, if number of approx points are 5, then we are going to say that it's a pentagon. So we are going to print out the pentagon text on the x and y coordinates. And if the number of points are 10, then we are going to just say that it's a star shape. So we are going to just say star, because in the star the number of points are 10. And then we are going to say that in any other condition, so we are going to just say else, and we are going to just remove this condition from here. Else, in any other condition, it's going to be a circle. Okay, so if approx length is 3, it's a triangle. If approx length is 4, it's a rectangle or a square. If 5, pentagon. If it's 10, it's a star. If it's nothing out of all these options, then it's a circle. You can also find out, for example, octagon or hexagon here. If it's 6, it's a hexagon. If it's 8, it's a octagon, and so on, right? Now let's once again come to this step, and in this step we just know that if the number of points are 4, then it's a rectangle or a square. But how can we find if it's a rectangle or a square? So let's decide that now. So what we are going to do for that is we are going to just say x comma y, and then we are going to just say w comma h for width and height. And there is a method called cv2.bounding rect, which is going to give us the x and y coordinates and the width and height of the rectangle, right? So we are going to apply that method. So cv2.bounding rect on our approximate variable or approx variable, which is going to give us the x and y coordinate and width and height. Now based upon the width and height, we can find out the aspect ratio. So we are going to just say aspect ratio is equal to float. First of all, we need to typecast the width into a float. So we are going to just say float w divided by height, and this will be the aspect ratio of the rectangle. Now if this aspect ratio, let's print out the aspect ratio also, so we know what aspect ratio we are getting using the rectangle or the square. And we are going to just say if this aspect ratio is between 0.95 and 1.05, then it's going to be a square, right? Because the width and height are almost same. Okay, so we just give some room for some noises. That's why we are providing here. Ideally it should be a 1, aspect ratio should be 1 in order to have a square, but let's say we are just approximating, so we can just say if it's 0.95, if it's greater than 0.95, and if it's less than, so aspect ratio is less than or equal to 1.05, then it's a square. Okay, in ideal situation you might want to give here 1, but in images it can be a little bit different, so we are just giving this limit. So if the aspect ratio falls in this limit, then it's going to be a square, otherwise it's going to be a rectangle, right? And I'm going to just say that if this is the case, then it's going to be square, otherwise. So in the else condition, so let's give this else condition here, else it's going to be a rectangle. So let's print rectangle in the put text. Okay, so this is the code which we have written. And now finally what we are going to do, we are going to just show the shapes image, including all the contours and the text which we have put on these shapes. So let's run this code and let's see if it works or not. So you can see now it's going to work like this. So all the contours are drawn across these shapes, and you can see the text on top of these shapes. So circle, rectangle, pentagon, star, triangle, and squares. What you can also do here is you can just change this text position using the x and y coordinates. So let's say I just want to change this y position to just little bit top of the shape. So I just added -5 offset here in the y-axis, and now you can see it goes little bit up this text, right? So now it's much visible, this text. And you can see rectangle and square text is not going up because we have declared the local x and y here also. So we can just say x1 and y1 here, and then run this code once again, and you can see this rectangle and square text is also moved little bit up. So I think the offset of 5 is okay to show these text on top of these shapes. So this is how you can detect simple geometric shapes using OpenCV. So I hope you have enjoyed this video, and I will see you in the next video.